In this video, we're going to discuss factoring polynomials by finding a GCF. If you'll remember, when we had a monomial, like a number, we have the number 9. We can break up the number 9 into its factors. It has factors of 1 and 9, it has factors of 3 and 3. Factors are sets of two numbers that we can multiply by each other to give us the original answer. So for example, if we multiply 1 by 9, we'll get 9. If we multiply 3 by 3, we'll get 9. Binomials and other polynomials also have factors. Let's look at that. Let's say we have the binomial 6x squared plus 3. Which two monomials or binomials or monomial times binomial can we multiply by each other to give us 6x squared plus 3? Let's see. Each of these, the 6x squared, this is a monomial, and the 3 is another monomial. If we find something that 6x squared and 3 are both divisible by, we can pull that out. Let's try that. 6x squared and 3 are both divisible by the number 3. So let's pull out a 3. And when we divide 6x squared by 3, we're left with 2x squared. When we divide 3 by 3, we're left with 1. So 6x squared plus 3 in factored form is 3 times 2x squared plus 1. This is going to be important when we have to solve quadratics. Quadratics are a graph, it's called a parabola, and we're going to want to solve for where this graph crosses the x-axis. And we're going to have to factor the equation for this parabola in order to find where it crosses the x-axis. Now, how do we know that we got it right, that 6x squared plus 3 is equal to 3 times 2x squared plus 1? Well, we can just multiply back. If we distribute the 3 over the 2x squared, and the 3 over the 1, we should get back to our original binomial. 3 times 2x squared is 6x squared, and 1 times 3, 3 times 1 is 3. So since 6x squared plus 3, since we got back to our original equation, 3 times 2x squared plus 1 is the correct factored form of 6x squared plus 3. Let's look at another example. Let's say we have 2x squared plus 4x plus 8, and we want to write this in factored form. So we want to rewrite it as something multiplied by something, because those would be the factors of 2x squared plus 4x plus 8. So each of these are monomials. 2x squared, 4x, and 8 are each monomials. And we want to find some monomial that each of these monomials are divisible by, so we can pull that out. So 2x squared, 4x, and 8 are all divisible by 2. 2x squared divided by 2 is x squared. 4x divided by 2 is 2x. And 8 divided by 2 is 4. So this is the factored form. 2x squared plus 4x plus 8 is the factor. The factored form of that is 2 times x squared plus 2x plus 4. Now, how do we know if we got it right? Let's distribute back and check. Distribute the 2 over the x squared, distribute the 2 over the 2x, and distribute the 2 over the 4. And we should get back to our original trinomial. 2 times x squared is 2x squared. 2 times 2x is 4x. 2 times 4 is 8. Since 2x squared plus 4x plus 8, since that is our original question, that answer is correct. 2 times x squared plus 2x plus 4. Later on, we'll learn how to further simplify this question, this answer that we got, using reverse FOIL, but that will be in a later video. Let's try another question. 18x squared plus 92. We want to find something that 18x squared and 92 are both divisible by, so we can pull that out. Now, how do we know what 18 and 92 are both divisible by? We can have our calculator tell us. If you click on the math, now we're in the math menu. Go right arrow once, now we're by num. If you scroll down to 9, it says GCD. Press enter. Now we're going to type in our two numbers. We have 18, we're going to type a comma, and we have 92. Close parentheses and enter. That tells us that the greatest common factor of 18 and 92 is 2. So we can pull out a 2, and we're going to do 18 divided by 2 is 9. So 18x squared divided by 2 is 9x squared. And 92 divided by 2, we can use the calculator. 92 divided by 2 is 46. And 18x squared plus 92 in factored form is 2 times 9x squared plus 46. Let's see if we got it right by checking. We're going to distribute. And this becomes 2 times 9x squared is 18x squared. 2 times 46, let's just check it, is 92. So since we got back to our original equation, the answer is correct. Let's try another one. 4x squared minus 6x plus 2. Now you might be able to notice right away that the only thing that these are all going to be divisible by is 2, because the smallest number that we have is 2. And since 4 is divisible by 2 and 6 is divisible by 2, our GCF is going to be 2. On your calculator, let's say you didn't know that. On your calculator, for GCD, what we just did, you can only enter two numbers. You could do 18, 92, you could do 4, 6, you could do 6, 2. You can't do three numbers. So let's say you had a longer equation. Let's say you had 18x squared plus 97x plus 108. You would have to test it out. You could do, say, math, num, scroll down to GCD. You would have to do, let's say, 97, 108 and press enter and see what you got. And then you would have to see if whatever you get is that divisible also by 18. So it's only one, so this wouldn't be factorable. But you would have to see, let's say you got something that for these two, there would be a number that's, let's say, 3. You would have to see, is this one also divisible by 3? Because you can't do, by GCD, you can't have a number, comma, the number, comma, another number. That's not going to work. Either way, let's go back to the question we were in the middle of. 4x squared minus 6x plus 2. So we decided that the only thing that all of these terms would be divisible by would be 2. So we're going to pull out a 2. 4x squared divided by 2 is 2x squared. Negative 6x divided by 2 is negative 3x. And 2 divided by 2 is 1. So this would be our answer. And of course, we would always want to check and redistribute to make sure we got it right. 2 times 2x squared is 4x squared. 2 times negative 3x is negative 6x. 1 times 2 is 2. Since we got back to our original question, this is correct. Let's try another example. Let's say we have 17x cubed plus 85x. So is there some number that 17 and 85 are both divisible by? Let's have the calculator tell us. Math, right arrow to num, scroll down to 9, enter, 17, 85, close parentheses and enter, 17. So we're going to apply to 17. But in this question, both monomials, 17x cubed, and the second one, 85x, they both have x's. The first one has x to the third. The second one has x to the 1. So we can pull out an x also. So we're going to pull out 17x. 17x cubed divided by 17x is 1x squared, or just x squared. 85x divided by 17x. Well, let's see what 85 divided by 17 is. That's 5 plus 5. And we pulled out the x from that, so this would be the factored form. Now let's make sure we got it right. We're going to redistribute. 17x times x squared is 17x cubed, plus 17x times 5. Let's do it on the calculator. 17 times 5 is 85. So this is 85x. And since we got back to our original question, this is correct. Let's try another one. X to the 6th plus x to the 5th plus x to the 3rd. So, we don't have any numbers. None of these variables have coefficients, so we can't pull out any numbers. Can we pull out variables? And we can. What is the greatest variable that we can pull out? Can we pull out x? Yes, we can. Because the first term is x to the 6th. So if we pull out an x, we'll still have x to the 5th left. The second term is x to the 5th. If we pull out an x, we'll still have x to the 4th left. The last term is x to the 3rd. If we pull out an x, we'll still have x squared left. So can we pull out two x's? And we can. If we pull out two x's from the first term, we'll be left with x to the 4th. If we pull out two x's from x to the 5th, we'll be left with x to the 3rd. If we pull out two x's from x to the 3rd, we'll be left with x. Can we pull out three x's? If we pull out three x's from x to the 6th, we'll be left with x to the 3rd. If we pull out three x's from x to the 5th, we'll be left with x squared. If we pull out three x's from x to the 3rd, we'll be left with 1. Can we pull out four x's? If we pull out four x's from x to the 6th, we'll be left with x squared. If we pull out four x's from x to the 5th, we'll be left with x to the 1st, or just x. If we pull out four x's from x to the 3rd, we can't do that because we only have three x's to start, so we can't pull out four x's. So the most that we could pull out is x to the 3rd. Let's do that. We're pulling out x to the 3rd. So from x to the 6th, we have left x to the 3rd. If we pull out x to the 3rd from x to the 5th, we're left with x squared. If we pull out x to the 3rd from x to the 3rd, we're left with 1. So this is the factored form of x to the 6th plus x to the 5th plus x to the 3rd. Let's multiply back to make sure we got it right. X to the 3rd times x to the 3rd is x to the 6th. X to the 3rd times x squared is x to the 5th. X to the 3rd times 1 is x to the 3rd. Since we got back to our original equation, this is correct. Let's try another example. Let's say we have 17x to the 3rd plus 85x squared plus x. Now before you go run to your calculator and immediately try to find the GCF of 17 and 85, you want to realize that the coefficient of x is just 1. So even if there's a GCF for 17 and 85, you won't be able to pull it out because you can only pull it out from two of the terms, and you're not allowed to pull out a number from two terms and not one term. So we're not going to be able to pull out any numbers in this question because of that 1x that doesn't have a coefficient, or just has a coefficient of 1. So what are we going to be able to pull out? Will we be able to pull out anything? Let's see. Can we pull out an x? And we can, because if we pull out an x from the 17x cubed, we're left with 17x squared. If we pull out an x from 85x squared, we're left with 85x. If we pull out an x from 1x, we're left with 1. Can we pull out x squared? No, we can't. Why can't we? Because the 1x, the last term, it's only x to the 1, which means we only have 1x. So if we can't pull out two x's if we only have one x, so let's pull out an x. 17x cubed divided by x is 17x squared. 85x squared divided by x is 85x. And 1x divided by x is just 1. Now let's multiply back to make sure we got it right. 17x squared times x is 17x cubed. 85x times x is 85x squared. And 1 times x is just x. Since we got back to our original question, this is correct. Let's do one last problem. 19x squared plus x plus 5. Can we pull out a number? We can't, because even if there would be a GCF of 19 and 5, which there isn't, we only have a 1x over here. So the greatest number we could pull out, and we don't bother pulling out a 1 because when you multiply by 1, it just stays the same. So we don't bother pulling out a 1. There are no numbers we could pull out. Can we pull out a variable? We have an x in the first term, we have an x in the second term, but the 5 has no x, it's just a constant. So we can't pull out an x. So there's no way for us to simplify this using GCF. There might be a way to simplify it using a different method, but there's no way for us to factor this using a GCF.